Okay, June 11, question 1 of 5. So this first question has got years 4, 5 and 6, and it's looking at people who can swim and can't swim. So we've got a two-way table going on. You can do it without the two-way table, but I just find it a lot easier doing it with it. So you'll draw your two-way table out. So we've got years, I'll put years along the top. And then, so we've got year 4, year 5, year 6, got total there, and then we've got can swim and cannot. We'll also have an extra column here if the total goes. And all I do is populate the data based on reading through. So there are a total of 96 children. 37 of these children cannot swim. 11 in year 4 cannot swim, so 11 in year 4 cannot. 21 in year 5 can. 30 children in year 6, and 18 of these 30 children can swim. So then in terms of adding things on, we've got 12 there, adds down to 30. Going across we've got 23, so that'll be 14, then make up to 37. This number here will be 59 to make it up to 96. We've got 21 and 18, which is 39, so that'll be 20. Adding down then gives you 31, and adding down here then gives you 35. Check adding these numbers together, you get 96. And the question is, work out the number of children in year 4 who can swim. So year 4 who can swim will be 20. Part 2. Work out the total number of children in year 5, so that's 35. And again, you can just write these things down then. Then on to question 2. We've got a scatter graph, and it says show this information on the scatter graph. So we've got maths 12 and then science 14, and then we've got maths 17 and science 20. That's the information. Then what type of correlation does this scatter graph show? So this is part B. It's a positive correlation. Then part C, estimate the science mark for David. So what we've got to do here is we're given a mark, David's mark in maths was 15. So you go up at 15 and then look for the main sort of area, which is around here. So I think 17 would be a good answer. They are allowing from 16 to 18, so including those two numbers. Question 3. So we've got builder mix makes concrete. 1 cubic centimetre of concrete has a weight of this. 15% of the concrete is water. The rest of the ingredients of the concrete, cement, sand and stone. The weights of these ingredients are in the ratio of 1, 2 to 5. Work out the weight of cement, of sand and of stone in 1 cubic metre of concrete. So 1 cubic metre we already know is 2,400 kilograms. So let's go through a few things. So we know that first of all we've got 2,400 kilograms to play with. Water, that consists of exactly 15%. So 10% of this, divide it by 10, you get 240. 5% then you half it. That'll give you 120. Add the two together, that's 360. And then you can take 360 then off your overall total, which will then give you 2,040 kilograms. You're then going to share that between the ratio. So we've got 1 to 2 to 5. So if we add the ratio up, which is 8 parts, then divide it into this, because 8 parts will then tell us what 1 part is worth. So dividing 8 into this. Again, it's calculator, so you can just go straight for the calculator if you want. So that's 255. So we then know that Cement is going to be 255, it's just one part there, so cement is 255. Two parts then, we'll double that. Double that then gives you the sand, which is 510, and then you've got 5 parts, so times this number then by 5, and that will give you then the stone, and the stone will then be 1,275 kilograms. Question part 2, will this be enough cement for a builder mix to make 30 cubic centimetres? Now, builder mix needs 30 cubic meters of concrete. So, cubic meters, that's what they require. Builder mix has only got 6.5 tons of cement. So it wants us in concrete. Will it be enough? Well, first thing to do then is take your cement amount from the first part, because that's for 1 cubic, and then times that by 30. So we can then get 7,650 kilograms. And we're told that we need that amount, so that's the amount that are required. We actually have 6,500, because tons times by 1,000 gives you kilograms. So then we'd actually be left with not enough, because we'd be still requiring 1,150 kilograms. So you can say not enough, and then you can say by 1,150 kilograms. Question 4 starts the stem and leaf. Show this information in an ordered stem and leaf. So as we're going through the numbers, I think what I'd first do is just write them on this side. So we've got 160, 173, 148, 154, 152, 164, 179, 164 again, 162, 174, 168, and then 170. Put these in order then. So an 8 goes in here, 2 and a 4. We've then got 0, 2, and we've got 0, 0, 4 over there. Put that down one. So we've got 0, 2, 4, 4, and 8. And then we've got 0, 3, 4, and 9. Now what you must do here is also put a key. So at that point then I'd just scribble this out and then just write down an example. So 1/4/5 means 145, and what are they in this? Centimetres. So that's that one. Then we're given, so this is for part A, 4A. 4B then asks us, there are 13 boys in the class, asks us to compare heights of the boys with heights of the girls. So to compare them, we're looking for 3 marks here. So step 1 is we need to either compare the medians or the means. So what I'm going to do is compare the means here. So the way I would do that, I'll just put a little note here for you, is add them and then divide by how many there are. Just going to save a bit of time in the talk through. So I've pre-prepared this. So the girls, when you add all their numbers and then divide them by 12, the girls' mean comes at 164, and then do the same thing with the boys, but divide by 13 because there's 13 boys there, and their mean comes in at 170 roughly. And we then look at height. So you say in general, or on average, sorry, on average, boys are taller than girls. And then the other one I'd do is range. Now range is the biggest number to the smallest number. So again, pre-prepared this, so the biggest number, take away the smallest number with the girls, will then give 31, and then the boys doing the same thing, the boys then will be 27. Now what this tells you is how spread apart the data is. The bigger the number, the more spread the data is. So girls have less consistent heights because their range is bigger. That's question 4 now. On to 5. So we've got Denzel here. He's got his 4-sided spinner. The sides of the spinner numbered 1, 2, 3 and 4. The probabilities are there. You call, this time you've got an X in, so you've got to deal with the fact that you've got an X. It says in terms of X, probability to land on a 2. So what you normally do is you take away from 1, because the probability of all events happening is 1, and take off your 0.3, take off your 0.1, and then take off your X. So that will then give you, this is 0.4, so take off from 1, 0.4, that gives you 0.6, and that's minus X. That'll be your answer for part 1. B, then work out the probability that the spinner will land on either 1 or 4. So probability that it lands on either is, or the or rule is that you add the probabilities. So probability of 1 or 4 is equal to the probability of 1, add the probability of 4, and that gives you 0.4. We've then got Denzel. He spins the spinner 300 times. Write down an expression in terms of X, the number of times a spinner is likely to land on 3. Well, it's just the probability of 3 times by 300. So we've got 300 and then X, because we don't know what that is.